Hi, welcome to the Collinearity in Three Dimensions video from the vectors topic of higher maths. Now you've already done collinearity and straight line topic, but what we're going to look at is using vectors to show it because it's much more straightforward using vectors in 3D than it is using gradient. So I'm going to do that now. Okay, now this is what we looked at before in straight line. To prove that points are collinear, we found that the gradients were the same, and that meant they were parallel. And since there was a common point, they had to be collinear. Now it's going to be very similar to this. The only difference is going to be we're not going to use gradients to show they're parallel. We're going to use vectors to show they're parallel. Now parallel vectors, for two vectors to be parallel, one has to be a multiple of the other. And if you think that, that's very immediate. If you have one vector that's just the same vector but longer, you're going to be pointing in exactly the same direction. Okay, so if u, for instance, was 3 lots of v, you're going to have exactly the same vector pointing exactly the same direction. It's just going to be a different length. Okay, so if one vector is a multiple of the other, they have to be parallel. And conversely, if they're parallel, then one has to be a multiple of the other. Okay, so that's the only difference. We're going to use this to show that they're parallel rather than gradients. Okay, now there's a quick note for you. We'll do that example after you've copied that. Just pause it for a wee second, copy that down. Right, cheers. Okay, so to prove that they are collinear, we've got 3 points here. A, B, and C want to prove that they're collinear. So we have to prove that one vector is a multiple of the other, and if they're a multiple of the other, they have to be parallel. So let's find two vectors. AB, first of all, is B subtract A. So that's going to be -2, -1, -2, subtract -5, -3, -7. Okay, so that gives us 3, 2, 5. And then BC is C subtract B, which is 4, 3, 8, subtract -2, -1, -2. Okay, so that's going to be 6, 4, 10. Okay, now that should be relatively straightforward to see, but BC is 2 lots of AB. Okay, and therefore AB is parallel to BC. And remember, this is where we have to be really thorough with our explanation. So state what you've done, what that means, and then since B is a point in common, A, B, and C are collinear. Okay, so you can see it's actually very, very similar to what we've done before. The only difference is here in proving that something's parallel. And that's the only bit they can be tricky, and it'll just be different multiples, okay, rather than being nice and easy with two. I'm not going to do any more examples because it's a skill you already have. It's just using those vector stuff to find the parallel rather than gradients. Okay, you'll do more practice with that in class. Let me know if you need a hand in anything. Cheers.